Okay, looking at this next question, it's incredibly wordy. It is a real A-level question from the past. It's one from the old London board, which then went on to become Edexcel later on. Not your board, but it is a real A-level question. The carburettor for a particular motor car is manufactured at one of three factories, X, Y and Z. So if I was doing this in the exam, I would now be writing down X, Y and Z, because they're important, and then delivered to the main assembly line. Factory X supplies 45%. Factory Y supplies 30%, and Factory Z 25%. So basically, if I was in an exam, I would summarise those 4 lines of text with that little bit of writing there. Okay, makes it much clearer just to do it like that. Of the carburettors manufactured at Factory X, 2% are faulty. So over here, I'll put that down as well. Y, 4% are faulty, and Z, 3% are faulty. So I've now worked out that we've got these numbers here are where they're made, and those numbers there are whether they're faulty or not. So I've summarised everything up to that point just in that information there. Let X, Y and Z represent the events that a carburettor chosen at random from the assembly line was manufactured at X, Y or Z respectively, and F denote that it's faulty. That all makes sense, just using some symbols. So we've dealt with everything up to there. Part A, express in words the meaning of Y intersection F dash. That's the first one. So what does that mean in words? If you're not allowed to use the sort of intersection and the symbol up there, what does that actually mean in sort of real life sentence? Anybody?
Yeah, that's Y, but not faulty.
Yeah. So it's made in factory Y and is not faulty. Made in factory Y and is not faulty. The not bit because of the dash on the F there. Then the next one we have is Y union Z. So what's the real life meaning of the expression Y union Z? Anybody else? Eve, what's Y
Is it
standing?
Y and Z?
Right, not the and. Okay, the union is or. Yeah, okay. So that means it's made in either Y or Z, and technically, or both, which actually won't happen because they're not made in both. But technically, that's what it means. It's Y or Z or both of them. But that actually won't happen. So Y or Z will be fine. Your union is or, and the one with looks like an N is like the word and. And if you think of and's got an N in the middle of it, that may be one way you can help yourself to remember those things. Okay, so the question then says, sketch a Venn diagram to illustrate the events X, Y, Z and F. Include in your diagram the probabilities corresponding to the different regions within the diagram. So you've got to do a Venn diagram of this now. Oh, it's missed out B. Okay, sorry. Okay, missed out B. Let's do B next. Thank you. So part B, we've got to calculate, first of all, X intersection F. Okay? Don't need to smudge that. X intersection F. What does that mean in words, first of all?
X is faulty.
Yeah, it's made in X and it's faulty. So we've got the basic information, the numbers up there. What do I do to find the probability it's made in X and it's faulty? What do you do from GCSE level for the word and? Times. So it is made in X, that's probability is 0.45, and is times, and faulty at X is 0.02. We're doing them as a percentage. What do you get if you times those together? Horrified looks on my face when people reach for calculators right in front of me. What have you got, Tabby?
0.009.
0.009, yeah, that's correct. Okay. We've then got to do Y intersection F. So using exactly the same system, it'll be the y probability, which is 0.3, and the y40, 0.04. Who's going to be brave and do that without a calculator at A-level?
Yeah, 0.00.
There'll be 3 things after the decimal point, because you've got 3 digits after the decimal point.
Yeah.
3 fours are 12. That's 2 things after the decimal point. That's 3 things after the decimal point. Okay? And the final one is Z and 40. Following the same way, Z is 0.25, 40 at Z is 0.03. Go on, can somebody give me a quick answer to that one? 0.75, yeah. 325 to 75, and 1, 2, 3, 4 digits after the decimal point. Now then, part C is this Venn diagram bit. Now I'm going to do it slightly differently, because I think it's a bit more helpful here. Because if I was going to do it with circles, I'd have to have a circle for X, a circle for Y, a circle for Z, and a circle for F. What do we know about X and Y and Z? And ideally, I'd like somebody to reply with a phrase that I taught you, I think, last lesson. Brilliant. Yeah, they're mutually exclusive. What does that mean?
They can never happen at the same
They can never happen at the same time. What does that mean in the drawing process?
They must be separate.
They must be separate. They don't overlap. So, when I'm just going to do this now, rather than put circles in here, I'm just going to split it up into 3 bits, because they're not going to overlap. I'm going to say this bit here is X, that bit there is Y, that bit there is Z, and nothing happens in this question outside factories X, Y or Z, so I needn't have any other section.
Mine's a question about the question B.
Yep,
Say there was like 100 items,
yep.
and there's 3% of them, wouldn't that be 3 out of all of the things coming from there? So wouldn't it be 3%?
No, if you look back at the wording of the question, of the carburettors manufactured at factory X, 2% of 40. Not 2% of all of the ones made anywhere. It's just then, if they come from factory X, 2% of those are 40.
So it's 2% of 45.
Yes, it's 2% of the ones made at X, so it's 2% of the 45. That will give you the overall percent. So what that means from our calculations back here, where we had this answer here, that answer, what is that number as a percentage?
0.9%.
Yeah, 0.9%. That means out of all of them that are made in all the factories, 0.9% of them will be 40 ones that came from factory X.
Right, okay. I was just confused because
Okay.
it's such a big number
Yeah,
in terms
that's
of...
fine. Okay? So back here, I've got my 3 factories, X, Y and Z. I've just split them up into rectangles. It's just easier if there are no overlaps. Now, what else have I got to incorporate on my Venn diagram that isn't there so far?
The 40.
40, yeah. And to be honest, I just would do it like this, to show that this section down here is 40. And the third thing along the top row is not 40. Because you've got then 6 different sections, and that's all that you want. So if there are no overlaps, if they're all mutually exclusive, I think it's just easier doing it like this than trying to have all the different circles overlapping or not overlapping and things like this. So, what can I put in here? Now if I uncover my answers to part B again, which I've got here, that 0.009 up there, which box does that go in? Yeah, so that goes down here. That 0.009, which was made in X and 40, that goes down in there. My Y and 40 I can put in, and my Z and 40 I can put in. Now, I know that altogether the probabilities in here, or the numbers in here, have got to add up to 1. Now I know that X, 45% of the whole lot are made at factory X. So in this X section here, everything has got to add up to 0.45. Well, if there's 0.009 here, what do I do to work out the number that's going to go in this top bit of x?
Take away the faulty number.
Yeah, take away this one. Yeah, so this number here is going to be my 0.45. Take away the number that's already in that section. And if you do that, you get 0.441. And you can do that for each one. I know earlier y is 30%, so there's a 0.3 in this y section here. And if there's 0.012 down here already, then up the top it's going to be the difference between the two. And if I work that out, it's 0.288. And I can do the same for z. I know there's 25% in z altogether, and I know there's some of it down here, so if I do that taking away, I get 0.2425. Now I've got the probability in each of those sections. So part C, I think, was said, sketch the Venn diagram, indicate in the diagram the probabilities corresponding to the different regions within the diagram, and that we've now done. So let's see if we can answer the rest of the question. Find the probability in part D, a carburettor selected at random from the main assembly line is faulty. Now I've got this table here, how do I get my final answer? I just want to know what's the probability that one is faulty.
Do you add them together?
Add the faulty.
Just add that bottom row together. Yeah, okay. Just add the bottom row together, and if you add those bottom row together, you should be getting 0.0285. And that is the probability that you will get a faulty carburettor from your factories as a whole. And you should also know, going back to your question earlier, Laura, if you add up all of those probabilities, they should all add up to 1. Everything should be covered. So you can see from here that factory X makes 44.1% of the carburettor. Well, sorry, I'll say that again. Of all the carburettors that are made, if you made 100, 44 of them would come from factory X, and they would not be faulty. You can sort of look at it like that. Okay.